Hello, I am Miracle, and today me and Rocio, who's recording, we are going to teach you how to do calculus! AB, by the way.
My name is Rocio, and I'll be teaching you guys how to do the solid of revolution, the disk method. Basically, we're going to find the volume of the 3D solid formed by the graph revolving around the x-axis. We're given the formula y equals 2x from 0 to 2, which revolves around the x-axis. Since we're revolving around the x-axis, we are going to use the horizontal axis of revolution formula, which is v equals pi integral of a to b f of x squared dx. So I'm going to graph out the function y equals 2x. Which should look something like that. And since we're giving the barrier of 0 to 2, we're going to find the volume of this part of the graph revolving around the x-axis, which should form a 3D solid, which should look something like this. So that will be we're going to try to find the volume of that shape. So we know that f of x equals 2x, and the barrier is 0 to 2, so a is equal to 0 and b is equal to 2. So we're going to plug that in. So pi integral of 0 to 2 2x squared dx. So that is equal to, so it's pi integral 0 to 2 4x squared dx. So now we're going to find the integral of 4x squared dx, which is just the antiderivative of 4x squared. And to find the antiderivative, we're going to add 1 to the exponent, so 2 plus 1, which is equal to 3, and we're going to divide it by what we got, which is 3. So this will equal pi times 4x cubed over 3 from 0 to 2. And now we're just going to plug in 2 and 0. So we get pi 4 times 2 cubed over 3 minus pi 4 0 cubed over 3. And this ends up canceling out and equaling 0. So now we're just going to continue on with this part. So pi times 4 times 8 over 3, which is equal to pi 32 over 3. So from that we get pi times 10.666, and when you multiply that with pi, you get 33.510, which ends up being the volume of that graph rotating from 0 to 2.
Hello, I hope you have learned how to find the solid of revolution, the disk method, from Rocio, who's recording me right now. And now I am going to show you how to go around the y-axis. Okay.
Hello, my name is Miracle, and today I will be showing you how to do the solid of revolution, the disk method, but around the y-axis. And it's a little bit different from going around the x-axis because you have to have everything in terms of y. So you're going to have to change the function into terms of y and the intervals in terms of y, and it's going to be going around the y-axis. So to start out, I generally just graph the function first. So that's what I'm going to do. So I'm just going to plot points to do that. So 0 will be 0, 1 would be 2, and 2 would be 8, which is off the graph. So let's just do a mini sketch of this. And we're just going to do half of the parabola. And that's pretty much it. And now since the interval is from 0 to 4, and we're going to be on the y-axis, we need to go from 0 here to 4 up here. And this is the axis, the interval along the y-axis. So now we can write the vertical axis formula since we are going around the y-axis, which is v equals pi integral from a to b of f of y squared dy. So you notice that this is f of y, so we need to change this equation, which is normally f of x, into terms of f of y. And to do this, we just need to solve for x. So y equals 2x squared. We'll divide the 2, y over 2 equals x squared, and then square root both sides. And this is now the f of y function. And we know that a equals 0 and b equals 4. So now that we have this information, we can just plug that straight into the formula after we do the 3D solid formed by rotating it around the y-axis. So we'll just pretty much replot this. And the sketch really doesn't have to be that great. This is our area that we will be using that's actually going around. And here it is going in a circle as our 3D object. So now we can go back over here with the algebra and plug the stuff into the function. So v will equal pi integral from 0 to 4 of the square root of y over 2 squared dy. And as you see here, we'll just square this. So that will equal pi integral from 0 to 4 of y over 2 dy. And you notice here we can take out a 1/2, and all variables inside of the integral just goes out to the outside and they'll hang out with pi. So we'll have pi over 2, the integral from 0 to 4 of y dy. And we will just have take the integral of y, and that's fairly simple, as all we'll be doing is adding. This exponent is 1, and we'll just add 1 and put that to the bottom, so that'll be 2. So it's just going to be pi over 2 times y squared over 2 from 0 to 4. And now this pi over 2 can still just be on the outside, and it can chill out for a second. Yes, I did say chill out. And this will equal pi over 2, and we're going to plug in 4, and we're going to subtract that and plug in 0. So it'll be 4 squared over 2 minus pi over 2 of 0 over 2 squared over 2, and this just becomes 0. So now all we have is this little bit left, so that equals pi over 2 times 16 over 2, and that equals pi over 2 times 8, and this will equal 8 pi over 2, which will then simplify down to 4 pi, and you take out your handy dandy calculator, and multiply that out, and you'll get 12.566 as your volume of this 3D solid. 12.566 units cubed, because we found the volume.
Hello. I hope you learned from me, Miracle, and Rocio, who is still recording, while we taught you how to do calculus AB. I hope you learned a lot. Bye-bye now.